let's review. Did we copy this down?
Yes. No.
Okay, so you need to get this down. In red, or just what's already there, that is the domain for these restricted domain values, or sorry, functions, sine, cosine, tangent. And in blue, I'm going to put the range. That one's a little bit messy, so if you have if anything is unclear, let me know. So again, blue is the range. What's in black already there is the domain. These are restricted domain functions. And I think we talked a little bit about it on Friday. Something's unclear, let me know, because I know this one in particular. This is theta such that 0 is less than or equal to theta, less than or equal to pi. So that one's a 0. These are just the domains and range. All this is telling you is what angles you can use for these restricted domain trig functions. It says I can use theta in between negative pi halves and positive pi halves for sine. This says I can use thetas in between 0 and pi for cosine. And this says I can use thetas in between but not including negative pi halves and pi halves for tangent. Do you see the capital S, C, and T? S, C, and T. So that's not a typo. So you should really have detail-oriented notes. This isn't a typo. It's because this is telling you that it's a restricted domain. The capital letters are telling you it's a restricted domain.
Is it important that the second, like, tan, cos, or sine is lowercase? The first one?
This one?
Like
So
problem.
this is a condensed way of saying this. Sine of theta such that theta is in between all that. So instead of writing all this, you just write this. Capital.
Okay.
Capital S implies all this. Capital C implies all this. So it's a space saver. Has everybody got that down? Is what you're writing down for the regular trig functions or the inverse trig functions? know. Do you see the -1? No. So is it for regular or inverse?
Regular.
This is for regular. We're going to write down for inverse in a second. You have to see the -1 for it to be an inverse. And in a second, we'll copy down the domain and the range for the inverse functions. I'll give you a quick way to know what it is. I'm going to erase these pictures right here, so hopefully you have them down already. Okay, so here's a quick visual to help you understand what the domain and range is going to be for the inverse functions. So if I want to go from the domain to the range, I have to hop on the ride sine. All right. If I wanted to get back from the range to the domain, which ride would I have to take? Sine inverse. Sine inverse. Do you see how that works? The sine I have to take to get from the domain, let's say I give you an angle theta. Well, I get an output of some number in between -1 and 1. Well, to get back, I have to take a number in between -1 and 1, evaluate it with sine inverse, and then I get back to that angle, right? Okay. So, what is the domain going to be for sine inverse? What is the domain going to be for sine inverse? This, right? This is going to be the domain for sine inverse, so add this to your notes. This is going to be the domain for sine inverse. And what's the range for sine inverse? Right, the domain for regular sine. Think back to what inverses do. You switch the x's and the y's, right? Isn't that what happened here? Mm-hmm. Very good, very good. So hopefully this visual helps, right? The only way I can go from here to here is by taking the ride sine inverse. Oh, I want to forget that. Well then, can you fill in what the rest of it is for cosine inverse and tan inverse? Cosine inverse, what's the domain for cosine inverse? Right, the range for cosine. This is the domain for cosine inverse. What's the range? That one, right? They just switch. Cosine inverse, range. Guess what? Same thing for tangent, right? This is important because it's going to help us solve problems in a couple minutes here. Okay, so that shouldn't have been too much to add to your notes, so we should be able to go forward, right? Do you have any questions about any of the diagrams on this page? What does sine inverse give you back? A ratio or an angle? An angle. Good. Right? That's from geometry, and it also tells you right here. What's my output for sine inverse? An angle. It says it all right here on the board. What's your output for tan inverse? An angle. And for cosine inverse? Okay, good. That's what this slide says, and we just saved a lot of time. If you hear me use these words, arcsine, that's talking about sine inverse. Arccosine, that's talking about cosine inverse. Arctangent, that's talking about tangent inverse. Okay, so you should know those words. Now we're going to try these together. All right, give me a different name for this one.
Arccosine.
There you go. All right, everybody say it with me. This one is also called
Arccosine.
I want to see how much you remember from Friday. What is this question asking me for? Somebody say it in words, concisely. What is this question asking me for? Yep, Paul?
Is it what angle theta such that the cosine of it you get back a value of negative square root of 2?
Yep, very nicely done. What angle theta such that cosine of theta equals negative root 3 over 2? Okay, I want to walk you through the steps on one of these, and then we'll go through a couple more together. If I want to undo this, what do I have to do to both sides? Cosine. To get rid of this cosine inverse, you have to do cosine on both sides. What happens with the cosine inverse and the cosine? They cancel. So I have negative root 3 over 2 is equal to cosine of theta. Now I'm trying to solve this. Just like Molly said, what angle theta such that when I take cosine of it, I get back a value of negative root 3 over 2. So it all says it right in this line. Well, how about this? What angle, or what's the restrictions on this angle theta? You have to look at domain or range. What's the restriction for this angle theta? Because you look back at the C and it's capital. What's the restriction for theta?
It has to be in between 0 and pi.
Okay, theta, you should star this. Theta has to be in between 0 and pi. How did you find that?
Written down.
And what was it under?
The capital C for cosine.
Right, the domain for capital C cosine, right? Okay, so we're trying to find this. Look at your unit circle. We're not using our calculators. Look at your unit circle and tell me what angle theta would give me that. What angle theta would make that happen? What angle theta would make that happen? 210. Oh, wait, pause for a second. Is that in the right restriction? Nope, something's wrong with that one.
150.
I heard 210. I know that's not correct because it cannot be down here or down here.
150.
You said 150, and that's the same thing as 5 pi over 6. 150 degrees, 5 pi over 6. I'm doing what to both of those? Taking what of it? Cosine? Cosine talks about x or y.
X.
What's the x value here?
Negative 3. Negative 3 over 2.
Is that what I'm looking for?
Yes.
There you go. There's your answer. Your answer, theta, is equal to 5 pi over 6 or 150 degrees. Yep. Because is that in my restricted domain? Mm-hmm. Yep. So good questions.
So if the C is capital, then we're supposed to know that it's just in the top half.
Is it in your notes?
Kind of.
Then it should be. If you see this, you should know it because it's in your notes and it's part of the textbook. All right? But yes, the answer is yes. Short answer, yes. How about this one? And how about we get a little bit smart about doing this? Before I even start answering this question, well, I'm trying to find an angle theta such that when I take sine of it, it gives me back a value of 3/2. Somebody take a look at that for a second and tell me what's wrong with this problem. Because there is something wrong with it.
In not gonna be able to get a y value of 3 over 2.
So what's telling you that?
Because it's either gonna be square root 2 over 2 is 1/2 or square root 3.
That's partially correct, but not quite. It doesn't have to be those ones. It can be anything in between two values. Your y could be anything in between two values.
Y has to be in between -1 and 1 3/2. It's not in between that.
So the y value here is -1. The y value here is +1. Sine, if you take a certain angle, you can be anywhere in between -1 to 1. Well, 3/2 is out of there, right? You cannot be there. So that means there is no solution to this problem. No solution. So you were getting on the right track, but it wasn't quite.
I'm gonna have to just like correct it because you can't. It wouldn't be undefined even if you can. If it was like in the
If it was 0.4, for example, if it was 0.4, there would be an answer. If it was 0.6, there would be an answer. If it was -0.2, there would be an answer, even though it's not on your unit circle. Only special numbers are listed on your unit circle. Only special numbers are listed on your unit circle. Not all of them. Okay, how about this one? Let's use our calculator. First off, let's set this up. What should I set this equal to? Theta. What can I do to both sides?
take the tangent.
You should do tangent of both sides. What does that leave me with? -√3 over 3 equals tangent of theta. Okay. Why don't you find this out with your calculator? In red, I'm going to highlight what you should plug in with your calculator. Your calculator knows the restricted domain of tangent. That kind of blocks things off. Your calculator knows the restriction on the domain of tangent. So all you have to do is plug this into your calculator and you'll get back an answer. So do that and tell me what you get. 120 degrees. Is that in the domain for tangent? No, I don't think so. Tangent's restricted -π/2 to π/2. 120 degrees is out of there.
Wait, it wouldn't be because it's two sides.
So in your calculator, what did you get? Something went wrong with your syntax when you typed it in. That's not. You should get -30. Everybody plug this into your calculator and see if you can get back -30, because that's correct. So you'll want to be able to do this. -30 degrees, or I could write equivalently negative radians. 30 degrees, same thing as what?
5/6.
There you go. So if you're not hopping on this train yet of being able to work with both, then that's something you need to work on, right? You need to be able to convert. Was everybody able to punch this into a calculator? Okay. Well, you should put it in degrees first, yep. Well, so you're putting this in. So if you're using the graphing calculator, type in tan inverse, and then type in -√3 over 3. So the buttons would be press this first, that's second tangent. Then you do minus sign, not subtract, but minus sign, √3 over 3, and then end your parentheses.
How would you do this?
Some we're not going to be able to use we're not going to be able to do by hand, so I want to show you some where you can and some where you can't. This one we could do by hand, this one we could do by hand, this one we can do by hand, this one we can do by hand, some other ones we're not going to be able to. this one, given that it's negative 30, let me think about how you would do that. Negative root 3 over 3. I'll think about it. Probably. But let me just show you multiple ways to do it so that you're better off. This one you can do by hand pretty quickly. What angle theta such that when you take cosine of it gives you 0 back? Look at your unit circle. What angle theta such that when you take cosine of it gives you 0 back? Pi over 2. That's correct. Is that in the correct domain?
Yes.
What's the restriction on the domain for cosine?
0 and pi.
0 to pi. I feel like a lot of you are kind of getting lost, so you need to ask questions or you're not going to be able to get anywhere. Is everybody able to see that it's pi over 2 for this answer? Yep. Theta is equal to pi over 2. Leela, let's hear you spell this one out for us. Number 8, what is it asking for? Okay. Figure it out. Ask somebody at your table.
Guys, how do you say that?
Somebody at your table should know how to say this. We said it 5 times, 4 times today. All right, I hear half of it. Such. Almost there. When you
Take the sine of it.
pass it off to somebody else, who's got this?
Hey.
All right, well, I'm going to stop wasting people's time. How do I say this? Somebody give it to me. Come on, I'm really worried if you guys cannot do this. Do this.
What angle theta such that when you evaluate it with sine, you get negative root 2 over 2?
Look back at your classmates and tell them.
What angle theta such that when you evaluate it with sine, you get negative root 2 over 2?
Okay, do you guys have that in your head? I'm going to ask you again on the next one. All right, this is what it's asking. Sine of theta equals negative root 2 over 2. What angle theta is that? So that's your job table. Find me out what angle works. Okay, so I'll give you 30 seconds. It's a quick look at the unit circle. Somebody got an answer? What is it? 7 pi over 4. Now you're overshooting again. Huh? What's the domain?
Domain is like this side.
What's the domain? It is, but it's spelled out a certain way. How is the domain spelled out for sine? It says going between
1
negative pi over 2 and pi over 2. Now, hold on. You told me which one?
in my unit.
You said 7 pi over...
7 pi over 4.
Now, hold on. Is that in between pi over 2 and negative pi over 2?
Yeah.
No, it looks like it is. You're right that it looks like it is, but that is not. 7 pi over 4, if you put it into your calculator, is 300 and what? 15 degrees? Is that in between negative 90 and positive 90? No, it is not.
Oh, maybe it's negative 30.
So it's negative pi over 4. Okay, do we have agreement that this right here is negative pi over 4? Okay, so one way to write this answer would be negative pi over 4. Another way would be negative 45. There is a big difference between those two answers. Biggest one being one's right, one's wrong. You had the right idea, right? But you need to pay attention to the domain. So yes, answer for this one, theta is equal to negative pi over 4. This would be a great chance if you're struggling at one of these tables here and you don't understand something to ask a question. So I'm going to open it up. Do you have a question on how do we come to these answers? Jesse.
How do you go from sine of theta equals negative square root of 2 over 2 to find it on the unit circle.
To finding this on the unit circle?
Yeah.
Sine tells you about what values, x or y? Y. So this is saying find me the angle that's associated with a y value of negative root 2 over 2. Find me the angle associated with a y value of negative root 2 over 2. Can you do that? You got it. Does that help?
Well, all the ones were given on the unit circle.
We're going to see one right now that is not on the unit circle.
So we use like the calculator.
There's some where you're going to be able to use a calculator, and I'm going to tell you, and then some where you're not. Yep?
Can I ask Elias to say that again?
Mhm.
Like, Elias, can you say that again?
What?
Can you read one?
What do you mean?
Just read the silent.
Read the
Oh.
next one. Read the next one.
Yeah, read that.
Okay, it's unrelated to the last question. Are you always
It was-
going
Read one. Fine, then read
Okay,
one.
read.
No, just read
Not
one.
always. Nope.
Okay,
So I'll show you one in a
Okay,
second.
So this one, right? Sine of 2 over 2.
Speak loud.
Okay. What angle?
Hey, you guys-
theta when evaluated, no, yeah, when evaluated, no, such that when you evaluate it with,
Wait,
Such that.
yes, such that when you evaluate it with sine, cosine, and tangent, gives you a value of whatever this number.
Yes.
Okay. Last thing we have to do today. I have to be able to answer these ones. Both of these look like they're asking the same thing, aren't they? Okay? These look like they're asking the same thing, but they're not. What's wrong? What's different between this one and this one? Say it more concisely with mathematical language. What's the difference between number 10 and 11?
The constraints are different.
The constraints. What are we constraining?
Y value.
The domain, right? Yep. So the constraints on the domain are different. So let's take a look at this one. How do I solve this? Well, first step is look at your domain. So first step, look at domain. All right. I have a domain of negative pi over 2 to pi over 2. Well, now I need to be able to solve it. From geometry, how do you solve this equation? What do you do to both sides? Not cancel. How do you undo the sign? You do sine inverse on both sides, correct? So that is theta is equal to sine inverse of 0.4. Well, sine inverse of 0.4. Let's type that into our calculator because luckily this is Papa S, all right? Big S, right? That's the same thing, same domain restriction. Negative pi over 2 to pi over 2. Papa S. All right? So put it in your calculator. Tell me what it gives back. How about just round it to the 100 or the tens place, like in the question? So everybody should be inputting this into their calculator.
Mr. Russell, are you just saying that beta is big S or sine beta?
I'm saying this is the same thing as big S sine, all right? Because look at the domain restriction, negative pi over 2 to pi over 2.
And that's just how it was like with the other video.
So you punch this into your calculator. What did you get? Did you punch it in? Okay, so class, you got 23.6 over here, yes? 23.6. If not, you're doing something wrong.
Oh, I didn't get one.
23.6 degrees. This goes back to what Calvin was asking. This is not a number on the unit circle. 0.4 is not a number on the unit circle. When you see a number that's not on the unit circle, that means you have to use your calculator. So if you look at the next one, now my domain's restricted to what? 90 to 270. So first step, look at domain. Look at domain. if it's not Papa S, like it was in the last one, maybe we should draw ourselves a picture. I'm restricting it to 90 to 270. 90 to 270. What hemisphere am I shading?
Left.
Okay, 90 to 270, yep. What y value am I looking for? 0.4. Let me ask you, on the last one, when we were in this side, when I was on this side, what was the angle that made that happen? Would you agree that's right there? About? Well, take a look. What was the y value right here?
It's 0.4.
0.4. Give me directions on how to get to the 0.4 on the other side of the circle. Yep. Not quite, because then I'd be down here. Nope. 180. I'm down here. Is that the same y value? What's the y value down here?
It would be like
No, that would do it all the way
I heard it reflected over the y-axis. There's one way you can do that I can think of. All right. Go like this. Wouldn't you agree that I just have to go directly left?
yes.
Okay. Well, how do you do that? This is a reference angle. This is 180 degrees. 180 minus
The
reference angle. 180 minus reference angle. What does that give you? What's the reference angle?
22.6.
180 minus 23.6. What is that? 156.4. Type this into your calculator to check your work. Is sine of 156.4 about 0.4? Type that in your calculator. See if that's true. So give me a thumbs up when you check. Yep. So this theta that we're looking for, theta equals 156.4. Now, do not go and overextend this. This trick does not work every time. All right? It works when you think about it critically. Right? If you had an example where you needed to get to this side, would it make any sense to take 180 and subtract off the reference angle?
No.
No, because I needed to end up down here. It depends on where you need to land. Right? One last one to do together before we leave. I think we can do it in 2 minutes. Papa T, right? What's the restriction on the domain?
Negative pi over 2 and pi over 2.
Negative pi over 2 to pi over 2. Hold up. Can you punch Papa T into your calculator? Yes, you can. Because it's a restricted domain and your calculator's smart. It knows this. So, type in, what am I going to type into my calculator? Somebody give it to me before we leave.
Inverse pi.
Yeah, an inverse of, tell me what angle you get.
3.4.
Anybody else? I got one person.
I got
Yeah, negative.
Negative 63 point. There you go. I suggest you try these ones tonight, and then you ask about them tomorrow, because this is pretty much the end of the section.
So when it's a capital letter, you just have to I feel like I do.
Good question from Katie. When it's a capital letter, can you trust your calculator?
Yes.
Yes. When it's a capital letter, you can trust your calculator.